Welcome to 4-2 Introduction to Functions on page 96. Our objectives are to define a function, to identify relations as functions given different representations, and then to apply the vertical line test to graphs, and finally to use function notation. What is a function? So a function is a special type of relation that pairs each domain exactly with one range value. How can you tell if a relation is a function? Okay, so over here we have a function table with x and y values, and then we have the ordered, let me get this out of the way, sorry. And we have our ordered pairs, okay? If a set of ordered pairs, or the domain and range value, to see if it's a function, okay? So right here our x values are -2, -1, 0, 1, and 2. If in a function table you see a domain or x value that repeats within the x value side, it is not a function, okay? It's not a function because you can't have one domain paired with one range and then that same domain paired with a different range. It won't work out like that. So for instance, I don't see any numbers that repeat on my x value side. Therefore it would be a function. So let's take a look, function or not. And if you're having a hard time with this, like I'm getting confused with the numbers and with the commas and the parentheses, then simply just write it out. So our domain in this set is going to be 2, 4, 1. Okay? No domain value has more than one range value. Okay? So therefore, it is a function. Okay? Over here, same thing. I have a 5, 4, 3. 5 pairs with 2, 4 pairs with 2, 1 pairs with 3. Now, you're probably saying, but the 2 repeats. So like right here, I see 2 2s, but that's in the range value. The range values can repeat as many times as they want to, and it can still be a function. But your domain value cannot repeat itself within that set of ordered pairs. All right? Down here, okay, we have 2, 5, 2, and 0. So over here, it says that 2 pairs with 3. So that okay. Then over here, it says that 2 pairs with 9. 2 cannot have more than one range or y value. So this would not be a function. Not a function. Over here, we have 7, 3, 7. In this first ordered pair, it says that 7 can pair with 6. In our final ordered pair, it says that 7 pairs with 9. Okay? The domain value of 7 has more than one range value, so it is not a function. Okay? Alright, so we just talked about function tables, about ordered pairs, so let's talk about mapping diagrams. So then, this is on page 97 in your books. We have A, B, C, D, and we have E and F right here. So if you draw the arrows that your book has, thank you, draw the arrows that your book has, A goes to E, B goes to E. Can A and B share the same range value? Yes, they can. Okay? Then we have C to F, and then we have D to E. So if you wrote out these ordered pairs, if you needed to, which you can, we have A, E, then we have B, E, we have C to F, and our final one is D to E. Do we see any domains that repeat in this function? No, we have A, B, C, and D. There's no repeated domain, so it will be a function. Now, again, a couple of our ranges repeat, but that's okay. That's totally allowed. So this would be a function. Okay, if we look at the one right next to it, we have A, B, C, D, and we have E and F. If you draw the arrows that your book has, it says that A goes to both E and F. So the ordered pairs would look like this. A, E, A, F. I know these are really sloppy, I'm sorry. Okay? So this right here states that the domain value of A has more than one range value, so that would not be a function. Okay? One of our last things we're going to talk about here is the vertical line test. Okay? So you'll be given a graph that looks just like this with a coordinate plane with a line drawn on it. Your vertical line test states in your book that when you draw a vertical line like this, if it hits at exactly 1 point on the line, not the graph, but on the line, it is a function. Okay? So let's draw one more. It hits right there. So this particular line, even though it's curved, would be a function. Okay? If we go to this one right here, it hits right here, and right here. Okay? So this particular line on this particular graph would not be a function. Okay? If you check out in your book, it says, when any vertical line intersects a graph at more than 1 point, the graph does not represent a function. Okay? So for instance, there's probably more than one domain that is matched with a different range. For instance, it probably has like 1 to 2 and then 1 to 3 or something like that. So you see the domain showing up in more than one more than one ordered pair. Okay? The last thing we're going to talk about is function rule. Okay? A function rule is an equation that describes a particular function. So this will be on page 98. And again, at the top of 98, it gives you more examples of functions and not functions with a graph and with a mapping diagram. So make sure to write those down as well in your graphs. Okay? So let's talk about function notation. Function notation. Okay, to write in function notation, you use the symbol f of x in place of y. So for instance, it's going to give you, let's see. So if it says the function rule y equals 4x, okay, you're going to put f of x in place of y, okay, all right, and then in your book, it gives you 4x. If I want to put in, let's say that x equals 3 here, okay, I'm going to fill in for these x values. So it means f of 3 equals 4 times 3. We're just filling in for x. Okay? So then this is going to equal 12. So then your y value, or your f of x, is going to be 12. So I told you that your x value was 3, and then we solved to get your other point in that ordered pair. So that would be 3, 12. Alright, so the ordered pair 3, 12 satisfies the function rule f of x equals 4x. Okay, inputting other values for the variable x will determine other ordered pairs that will satisfy this function rule. So let's do a couple more examples, shall we? Let's do if f of x equals 5x plus 7. Pardon me. And let's say f of x, let's say x equals -4. Okay? So let's just fill this in. So we have oops, not paying attention. F -4 equals 5 times -4 plus 7. Okay? So if that's the case, then this is going to equal -20 plus 7, which equals, oops, sorry about that, which equals a -13. So that coordinate is going to be, gave you the x equals -4, so -4, and f of x, again, just replaces the y, and it tells you that it's -13. So that is your coordinate for that one. That is a functional ordered pair for that function rule. Okay? So this is what I'd like you to do for the rest of the video, is to do the try these. Numbers 1 to 3. There's a little bit more that I'm going to talk to you about in class, but that's it for notes. So work on those. If you have any questions, we'll take care of them tomorrow. Okay? Good night. Good luck.